Your grandfather bought a television in 1967. It sat in the living room for 23 years. When it finally stopped working, a repair technician came to the house, opened the back panel, replaced a single component called a vacuum tube, charged $14, and left. The television worked for another 8 years after that. In 2026, the average flat-screen television sold in an American big box store will develop its first hardware failure between 4 and 6 years after purchase. When that failure happens, the repair technician, if you can find one willing to touch it, will tell you something you did not expect to hear. The part does not exist anymore. Not because the technology is too new, because the manufacturer discontinued the replacement component 2 years after they stopped selling that model. The part had a shorter lifespan than the television it was designed to fix. This is not an accident of technology. It is a decision of engineering. Welcome to the soldered backlight collapse. To understand what was taken from you, you need to understand what used to exist. The CRT television, the heavy curved screen set that dominated every living room from the 1950s through the early 2000s, was built like industrial equipment. Its internal components sat on through-hole printed circuit boards, large, accessible, individually socketed. A technician with a basic electronics education could identify a failed capacitor by sight. Replace it with a component available at any electronic supplier. The repair cost less than dinner. Those televisions lasted 15 to 25 years as a standard expectation, not an exception. When LCD screens arrived in the mid-2000s, the technology changed, but the repairability remained. Early LCD televisions used CCFL backlights, cold cathode fluorescent lamps, to illuminate the screen from behind. These were thin fluorescent tubes, replaceable as individual units. Repair shops stocked them. Online suppliers carried universal sizes. A failing backlight was a $40 part and a 2-hour job. Then the industry switched to LED backlighting. The stated reason was efficiency. LED backlights consume less power than CCFL fluorescent tubes. Thinner profiles became possible. Contrast ratios improved. The television got lighter, thinner, and cheaper to manufacture. It also became something engineers who work on them have a specific word for: disposable. The LED backlight in a modern television is not a single unit. It is an array of surface mount device LEDs, tiny semiconductor components, each smaller than a grain of rice, soldered at a factory in Shenzhen onto a flexible printed circuit strip. That strip runs behind the LCD panel. Dozens of strips, hundreds of individual LEDs, each one generating light, each one generating heat, each one degrading from the moment the television is first switched on. When one LED fails, and they fail at different rates, at different points across the strip, at unpredictable intervals between years 4 and 7, it creates a dark spot on the screen, a patch of black where the picture used to be. Sometimes it is a single point. Sometimes it blooms across a quarter of the display as adjacent LEDs are thermally stressed by their failing neighbor. The failed LED cannot be replaced individually. The solder joints are microscopic. The strips are not designed to be serviced. The correct repair is a full strip replacement, and here is the calculation manufacturers made and consumers never see. Replacement LED strips are model specific. The strip in a Samsung QN65 from 2021 is not compatible with the strip in a Samsung QN65 from 2022, even if the televisions look identical from the outside. Manufacturers discontinue parts production 2 to 3 years after a model is phased out of retail sale. A television sold in 2021 was discontinued from retail in 2023. Its parts were discontinued from production in 2025. By 2026, the strip that costs $35 to manufacture does not exist in any supply chain on Earth. The repair that would have cost $80 now costs the price of a new television. That is not a coincidence. That is the parts life cycle the manufacturer designed. Behind the LCD panel, between the main processing board and the screen itself, sits a component most television owners have never heard of: the T-Con board, the timing controller. Its function is precise and non-negotiable. It takes the video signal processed by the main board and converts it into the exact timing pulses required to drive that specific panel's pixel rows and columns. Every panel model has a different resolution, a different pixel density, a different gate driver configuration. Every T-Con board is therefore unique to the panel it controls. There is no universal T-Con board. There is no cross-compatible replacement. When the T-Con board fails, and it fails in a recognizable pattern, vertical lines across the screen, half the image missing, a display that shows flickering color bars, the only repair is an exact match replacement. T-Con board failures are the second most common hardware failure mode in flat-screen televisions, after backlight degradation. They occur most frequently between years 5 and 8, and because the board is unique to a panel that was itself unique to a model that was discontinued several years earlier, the replacement board exists in a window of availability that closes faster than the television's average failure timeline. Samsung, LG, and Sony all operate under the same supply chain logic. Parts production ends when the model generation ends. The consumer repair window closes 2 to 3 years later. The television's actual failure window opens at years 5 through 8. Those two windows do not overlap. That gap is not an engineering oversight. It is an inventory decision. When the T-Con board fails and the replacement does not exist, the technician says the same 4 words every time. It is not repairable. Assume the backlight holds. Assume the T-Con board never fails. Assume the hardware remains perfect. The television will still be killed on schedule, without warning through software. Every major television sold since 2016 is a smart TV, a hardware display running a proprietary operating system. Samsung uses Tizen, LG uses WebOS, Sony uses Google TV, Vizio used SmartCast. Each platform requires active software support from the manufacturer to remain functional. Active support means OS updates, security patches, and, critically, compatibility maintenance with the streaming applications that run on top of the operating system. Netflix, YouTube, Disney Plus, and every major streaming service update their applications constantly. New compression formats, new authentication protocols, new interface requirements. When a streaming service pushes an update that requires a newer API than the TV's operating system supports, the app stops working on that platform. Manufacturers issue OS updates to maintain compatibility. They do this for 3 to 5 years after a television model's release date. After that, the update cadence stops. The hardware is unchanged. The screen works perfectly. The backlights illuminate. The T-Con board fires on every frame. But Netflix no longer runs. YouTube crashes on launch. The television's entire smart functionality, the feature that justified its premium price tier, is gone. Completely. Permanently. This is not hardware failure. It is hardware murder. The physical device was executed by a software decision made in a corporate office with no notification, no compensation, and no recourse for the consumer. In the European Union, the Right to Repair Directive now requires manufacturers to provide software support for a minimum period aligned with the product's expected lifespan. In the United States, there is no equivalent requirement. American manufacturers discontinue software support on American televisions on timelines that benefit American manufacturers. That is not regulation. That is the absence of it. In every television built before approximately 2014, the LCD panel was held in place by plastic clips, guide rails, and screws. A technician who needed to access the backlight strips or the T-Con board could remove the panel, perform the repair, and reassemble the television. The panel was an architectural element. It could be removed and reinstalled without damage. Modern television panels are bonded. Manufacturers apply industrial adhesive between the panel and the bezel, between the bezel and the back housing, and between the optical diffusion layers that sit behind the panel itself. This bonding reduces assembly time at the factory. Fewer clips, fewer screws, fewer labor seconds per unit. At 10 million units per year, eliminating 8 screws per television saves a calculable fortune in assembly cost. It also eliminates repairability as a side effect that the manufacturer accepted before shipping a single unit. To access the backlight strips on a bonded construction television, the technician must separate the panel from the bezel. The adhesive that holds them together has a tensile strength that routinely exceeds the structural limits of the panel itself. Panel cracking during disassembly is not the exception. It is the expected outcome. A cracked screen on a television that was being repaired for a $60 backlight failure is a total loss. A $900 replacement screen, if it can be sourced at all, makes the repair economically absurd. The technician writes it off. The television becomes landfill. A television that cannot be disassembled without destruction cannot be repaired. That is not a design limitation. That is the design. Here is the structural fact that makes every layer of this problem permanent. Two companies manufacture the LCD and OLED panels used in virtually every flat-screen television sold in the world: LG Display and Samsung Display. Every television bearing a Sony logo, a Hisense logo, a TCL logo, a Vizio logo, a Philips logo, almost all of them contain a panel manufactured in one of two factories controlled by two South Korean corporations. Sony does not make Sony television panels. Samsung's television division buys panels from Samsung's display division at arm's length transfer prices that are negotiated to benefit the display business. Even the television brands that market themselves as competitors are buying components from the same two sources. This consolidation means there is no competitive pressure on parts availability, on repairability standards, or on product lifespan. When both panel suppliers operate under the same parts discontinuation timelines, there is no manufacturer who can differentiate on longevity. The lifespan of the product is an industry norm, not a brand choice, and industry norms, when they benefit every participant equally, are never reformed from within. The iFixit Repairability Score, the independent teardown organization that rates electronics from 1 to 10 based on how serviceable they are, gives current flagship televisions a score between 2 and 4 out of 10. Out of 10, the European Union's 2024 Right to Repair legislation requires spare parts availability for televisions for a minimum of 7 years after the last unit is sold. American legislation contains no equivalent mandate. American televisions sold in 2026 exist outside any legal framework that requires them to be fixable. The parts expire, the software dies, the adhesive seals the case shut, and the warranty runs for 12 months. Here is what the television industry does not want you to price out. Laser projectors. A modern 4K laser projector, a unit from a manufacturer like Epson, BenQ, or Hisense's projector division, uses a laser light source rated for 20,000 to 30,000 hours of operation. At 4 hours of viewing per day, that is between 13 and 20 years before the light source requires attention. The optical engine is modular. The components are accessible. The lamp assembly in most laser projectors can be replaced by a technician without destroying the unit. A 100-inch projected image from a $1,500 laser projector will outlast 365-inch Samsung QN series televisions purchased at the same budget over the same period. Commercial-grade displays. NEC and Sharp NEC manufacture display panels sold to businesses for digital signage, conference rooms, and control centers. These panels are built to commercial specifications: modular power supplies, accessible service panels, replaceable backlight assemblies, and parts availability guaranteed for a minimum of 5 to 7 years after purchase. They are more expensive per inch than consumer televisions. They last 3 to 4 times longer. Vintage plasma. The Panasonic ZT60 and Pioneer Kuro plasma panels, manufactured between 2008 and 2014, still produce black levels and color accuracy that modern QLED panels cannot match. They are repairable. Parts exist in secondary markets. A working Pioneer Kuro purchased for $400 on the used market delivers a picture that a $2,000 Samsung QN85 cannot reproduce, and it will still be working in 10 years. The television that lasts is not the one sold in the showroom under a promotional finance offer. It is the one designed to be opened, serviced, and owned. In 1967, a television was a purchase. In 2026, a television is a subscription you pay once at the register and keep paying every 5 years when the backlight dims, the T-Con board fails, the firmware dies, and the repair technician shrugs and says the part does not exist. The screen is not the product. The replacement cycle is. Stop buying the picture quality. Start buying the repairability. Because the television they sold you in 2026 was not built to last a decade. It was built to need replacing in one.